Now you come across a locked treasure box. There is no key for opening it, only a panel for inputting codes. Luckily, you find an ancient scroll sealed beside it. This scroll is said to contain the only code that can open the box. Inscribed on the scroll is a strange passage. Within the arc where the circle is halved, from one to the step before the straight is carved. Harvest the sign of every angle whole, and product them all as one shall go. Break the product to 45 equal shares, take aside only one that cares. Then mark the X as the fold shade must fall, to weigh and balance what remains of all. At first, it sounds poetic, but this is not poetry. It is a set of precise instructions. After analyzing it a little bit, you've found what the scroll is describing. From the first sentence, you are asked to look at all integer angles within a half circle, starting from 1 degree and stopping at the last whole degree before 180, which is 179 degrees. From the second sentence, you know that for every one of these angles, you must take its sine value and multiply all of those sine values together, forming a single enormous product. Next, the third sentence tells you to take that product and divide it into 45 equal parts, and you should keep only one of those 45 parts and discard the rest. Finally, the last sentence refers to repeatedly having a whole to 1/2, then half again, and again, and again, and fold X times until it exactly matches the value you obtained from the scroll's instructions. That X, the number of time you must fold by 1/2, is the code to the box. And only by finding this X code and inputting it into the panel can the box be opened. So the question is, can you find the value of X? Please think carefully and use your advanced brain. At its core, this puzzle asks us to find the value of X in the following expression. To do that, we must first simplify the huge sine product. Let us define a new variable p, which equals sine 1 degree times sine 2 degrees times all the way to sine 89 degrees. Now recall an important symmetry of the sine function. This means sine 91 degrees times sine 92 degrees times all the way to sine 179 degrees equals p as well. Meanwhile, sine 90 degrees equals to 1, so it contributes nothing and can be ignored. Using this symmetry, the full product from sine 1 degree to sine 179 degrees becomes p squared. Therefore, the value of X simplifies to the following expression. Now everything depends on finding the value of p. To compute p, we use the triple angle identity. Let's briefly review the derivation process of the triple angle formula. In this case, let theta take the values from 1 degree to 29 degrees. Then, sine theta covers sine 1 degree to sine 29 degrees. Sine 60 degrees minus theta covers sine 31 degree to sine 59 degrees. And sine 60 degrees plus theta covers sine 61 degrees to sine 89 degrees. This accounts for all sine terms in p, except sine 30 degrees and sine 60 degrees. Applying the triple angle formula 29 times introduces a factor of 1/4 to the 29th power, and including missing terms, sine 30 degrees equals 1/2, and sine 60 degrees equals square root of 3/2. Then we obtain p as the following expression. We now apply the same identity to the middle product again. This introduces 9 more factors of 1/4 and another sine 30 degrees and sine 60 degrees. So we can simplify p a little bit further. At this point, the triple angle identity can no longer be applied. As we know, sine theta also equals cosine 90 degrees minus theta. With this pattern, it allows us to pair terms as sine theta times cosine theta, which is the main part of the double angle formula. We apply this identity 4 times, introducing a factor of 1/2 to the 4th power. Also, we know sine 45 degrees equals to square root of 2 over 2. This reduces the expression further to this form below. Repeating the sine-cosine conversion and double angle identity once more, and introduce the factor of 1/2 square. We now have the p expression. And after we do some simplification to the factors, we can get the final form of p. Now, only one piece remains. How do we actually compute sine 36 degrees times sine 72 degrees? To do this, we construct a geometric model. Consider an isosceles triangle ABC, and let the vertex angle A be 36 degrees. Then the base angle ABC and ACB must be 72 degrees. Set the equal sides AB equals AC equals 1. And let the base BC equals M. Now bisect angle ABC with segment BD and point D lies on side AC. Since angle DBC equals 36 degrees and angle C equals 72 degrees, we have angle BDC also equals 72 degrees, and triangle BCD is also isosceles. That gives BD equals BC equals M as well. Next, observe that angle A equals angle ABD equals 36 degrees. Triangle ABD is also isosceles, which means segment AD equals BD equals M. Then we should notice that both triangles ABC and BCD are isosceles triangles with vertex angle 36 degrees and base angles 72 degrees. Therefore, they are similar. From similarity, we have AB over BC equals BC over CD. Substitute AB equals 1 and BC equals M. Solving it gives us CD equals M square. Now look at side AC, it equals to segment AD plus DC, which is M plus M square, and it equals to 1 as well. So we solve the equation and get M equals square root of 5 minus 1 all divided by 2, and discard the negative root. Next, drop a perpendicular from point D to side AB, meeting it at point E. Line D is also the median, so AE equals 1/2. Using the Pythagorean theorem, we get the value of DE. Then, in triangle ABD, sine 36 degrees can be written as DE over AD. Substitute values, we can get the value of sine 36 degrees. Next, drop a perpendicular from point A to side BC, meeting it at point F. This is also the median of BC, so BF equals half of M equals square root of 5 minus 1 all divided by 4. Using the Pythagorean theorem once again, we can calculate the value of line AF. Now we compute sine 72 degrees, which equals to line AF over AB. Since AB equals to 1, we have sine 72 degrees is exactly equals to the length value of line AF. We multiply these two results together, then this simplifies to square root of 5 over 4. Now, we substituting back to the p expression, we get the final form of p. Let's recall the original expression of x. X equals log base 1/2 of p squared divided by 45. Then after simplifying, we've got the final result. The value of x is, finally, 177. And this number is the X code that unlocks the treasure box. Once you entered 177 on the panel, the box opens and the reward is revealed. If you enjoy puzzle like this, and want more problems that challenge your math skills, please subscribe to Advanced Brain and keep thinking smarter.